Yes, I'm going to start a new topic that is indices, surds, and logarithms. Okay? That's what we are going to start with today. So we are looking at indices, surds, and logarithms. So our subheading is indices. That's what we are going to look at today. But before we start our lesson, let's someone to lead us in a short prayer, please. Someone to lead us in a short prayer.
Let's do.
Someone to lead us in a short prayer. Yes. Who is going to take us to do that? Of Mary. Of Mary, lead us in short prayers, please. Yes? Of Mary? Okay, if Of Mary is not there, then to Pista, please. Lead us in short prayers and start our lesson. Maya? Unmute your microphone and lead us in short prayers, please. Unmute your microphone and take us in short prayers. Yes? Yes, Lynette. Lynette?
Yes, teacher.
Okay, people, you lead us in short prayers now. You lead us in short prayers, understand?
Yes.
Lead us in short prayers, please.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Amen.
Heavenly Father, King of glory, we want to thank you for this day. We want to thank you for everything you have done for us, dear Lord Father. So Father, for us to attend the mass lesson, may you give us the spirit of understanding, so that whatever the teacher will teach us and we understand, Lord Father. We also pray for our parents that they may continue helping us down on our parents. We ask all this with the Christ our Lord. Amen.
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 Thank you, Lynette. So members, good afternoon once again.
Good afternoon.
Good afternoon, teacher.
How are we?
We are fine.
We are fine.
Let me hope for you had the right proportion of food, not too much. Let me hope people will not start dozing in my lessons when I'm not even seeing them. Ready? Ready?
Yes, teacher.
Let me hope you will not doze. Okay. So our heading, what we are looking at today, we are looking at indices, surds, and logarithms. So let's start with indices. To help us understand indices better, we have to remind ourselves on some of the concepts that we have already learned, because it's going to play a key role in helping us to understand this in what we call prime decomposition. Do you remember that? Prime decomposition. There's a topic that we look at when we are looking at factors, prime decomposition, or what we call prime product. Expressing a given number, in product form, in the product of its prime, factors, So from there we can is going to help us a lot in expressing what we call indices. So take for example, we have various methods that we use. We use the factor tree. I believe you remember that. The factor tree. Then the ladder method. The factor tree and then the ladder method. That's what we look at sometimes back. So like a question can be, can you express 64? 64 as a product of its prime factors. So we know prime numbers. We say prime numbers. These are numbers which have only two factors, one and itself. And these numbers we have already discussed them. We say these numbers are so prime factors or prime numbers. We have 2, 3, 5, not
5,
7. Then what?
7, 11,
11,
11, 13,
those ones
17.
like that, right? So these numbers they have only two factors, one and itself. So when they tell you to express 64 as a product of 8 prime factors, it means you have to decompose. You have to reduce these numbers using those factors. Okay. So now when we have 64, like we can use factor tree. So the first one, if 2 cannot, then you move to the next one. If 3 cannot, then you move to the next one until we reach the factor of 1. Okay. So we have 2. When 32 divided by, 64 divided by 2, it will give us 32.
32.
Then this one will give us 16.
16.
Then it will give us
8.
8. This one will give us
4.
4. Then this one will give us 2.
2.
Will give us 2. You continue dividing until the number cannot be divided anymore, until you reach a factor of 1. Right together. So you can now see that a factor, which is 2, is repeating itself. Don't you see that? 2 is repeating itself how many times? 1, 2. So we can say, so it implies that 64 is equals to 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Now, if you look at this, all these numbers they are to the power 1. They are to the power 1. They are to the power 1. So which means 64, when I express it in power form, it will be 2. Then you add the powers. How many times is it repeating itself? 1, 2, 3, 4, 5, 6. So it becomes 2 to the power 6. Are you together?
Yes, teacher.
Yes. So 64 is in simple forms is the same as 2 to the power 4. That one is when we express it in prime factors. What about someone you can talk of? What about 25? What about 25? You can have a number like 25. A number like 25. Can 2 go there?
No.
Can 3 go there?
No.
So we go for which one? 5, right?
5.
5.
So 25 divided by 5 will give us 5.
5.
5.
Then 5 will give us 1.
5.
So it implies that 25 is equal to 5 times 5. This is to the power 1. This is also to the power 1. So you can see how many times is
1.
So this one will give us 5 to the power 2, which is 20, which is
2.
5 squared. Right together.
Yes.
Yes.
So expressing numbers in that form, is what we call indices. Is what we call what? Indices.
Indices.
Right together.
Yes.
Yes. Can we do for more? Let's try it just to remind ourselves. Write down this question. Express the following numbers. Express the following numbers as a product of its prime factors. As a product of its prime factors. A, we have I can talk of 2,000, sorry, 401. We can have that number. B, we can have 125. Okay. Then C, we can have 32. Then maybe lastly D, we can have 81. We can have a number like 81. So can we work it out? Let's work it out. Let's work it out. Solution. So A, we have 2,401. So which method should we use? Should we use a ladder or we use factor tree?
A ladder.
We use ladder, eh? Okay. So can 2 divide that? Can 2 divide that? So if you are not sure, you come and you tell
No.
me. So you come and say 2,401 divided by 2. You see that is leaving a remainder. So that one is not. So which one do we take?
7.
7. Eh?
7.
So
Yes.
divide by 7. We get what? So 7 goes there, right? So it gave us 343. Which one again? 7 can still do that, right? Again by 7. By 7 it will give us
49.
But 49. Again
49.
by 7 will give us 7, right? Then again by 7 will give us 1. So it means now 2,401 is the same as 7 times 7 times 7 times 7. So which is the same as what? 7 to the power? Which power is that?
4.
7 to the power? 7 to the power of 4. Can you do the same for B? B, work out B. Work out any part of B. So in B, so 125 is the same as, just give me the answer. Is the same as? What do you get? 125 is the same as?
5 to power.
5 to the power?
5 to power 3.
5 to the power 3. Good. Then we have 32. What about 32? 32 is the same as? Is the same as?
2 to power 5.
It's 2 to the power 5. Good. Then D we have 81. 81 is the same as? When you decompose that, what do you get? Yes, Opio? Jacob, what do you get when you decompose 81? I mean 81, yes. We get 3 to the power 4, right? Remember, is that what we are getting?
Yes, teacher.
Yes.
Yes.
So the process of doing that is what we call prime decomposition. I brought that because it's going to help us in understanding indices very well. It's going to help us how we write indices very well. So you can say from my notes, we said an expression like 3 times 3 times 3 times 3 4 times can be written as 3 to the power 4. So which means 3 to the power 4 is an index. We call it an index. If it's only one, we call it an index. Okay? Then the plural singular is index. Then plural is indices. Right together?
Yes, teacher.
Yes.
Yes. So 3 to the power 4 is an index. But how do we read that? We read this one. So if I have 3 to the power 4, the 3 is our base. We call it a base. We call it a what? A base.
The base.
Then 4, this 4 is our together?
Yes, teacher.
Yes. So you write down an index. Index refers to 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 the power refers to the power index refers to the power to which a number is raised, to which a number is raised, to which a number is raised. That's what we call index. Are we together?
Yes.
Yes, index refers to the power to which a number is raised. Or we can say, or an index is the number of times, the number of times the base, the number of times the base multiplied number of times the base is multiplied by itself. The base is multiplied by it what? By itself. Are we together, students?
Yes, teacher.
Yes.
So that's what we talk. That's what we call an indices or an index The number of times a given base is multiplying itself. So if I write, like example, if you look at a number like 4, if I express it if I decompose 4, we know that 4 is the same as 2, is the same as 2 squared. So in this case, what is our base? What is our base?
2.
Our base is 2. Then what is our power? What is our power? Power is also
2.
power. So it means for us to get 4, 2 must multiply itself, which is the base. In this case, our base is 2. So 2 must multiply itself how many times? 2 times, which is
Twice.
2 times 2. The same, if I have 3 to the power of 4, it means 3 must multiply itself how many times?
4 times.
4 times.
4 times. So 3 times 3 times 3 times 3. So this is what we call an index. That's what we call an what? An index. Right together. So in a simple sense, when we talk of indices, we just say refers to the number of times or a power to which a given number is raised to. Right together.
Yes.
Yes. Now the power, what we call the power. Suppose, write it down. Suppose a to the power n. Suppose a to the power n is an index. Suppose a to the power n is our what? Index. Then a is the base. A is the what?
Yes.
The base. Then n we can give it 3 names. There are 3 names we use to refer to that. I can call it index. Okay. I can call it what? Index. I can call it power. Okay. Or I can call it exponent. Right together.
Yes, teacher.
Yes.
So how do we read? We read a to the power n. We read this one as a to the power n, or a exponent n, or a index n. Right together. That's how we read it. We read it as a to the power, or a index, or a exponent. Exponent what? Exponent n.
And
Right together, members.
Yes.
yes.
So we know what indices is now, right? Yes.
Yes.
All right.
Yes.
All right. Now let's look at now. There are certain laws that we must pay attention when we are looking at indices. So there are some laws which govern. Whenever we are talking about indices, there are some laws that we must remember. Okay, so let's say subheading laws of indices. 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 When working with numbers, involving indices, when working with numbers involving indices, comma, there are fundamental laws, which can be applied. Right together?
Yes.
Yes. Let's write down the laws. Law number one. Law number one. I will write them, then we explain them later, okay? Law number one
Yes.
is saying, suppose I have a to the power n times a to the power n. The law says this one is the same as a into m plus n. Are you together? So what you see that they must have the same base. The law is only applicable when they have the same base. So a to the power n times a to the power n is the same as a, which is now a single base, into n plus n. That's law number one. And the reverse is true. True. Number two, law number two, if I have a to the power n, I'm dividing it by a to the power n. The law permits me to say this is the same as a into m minus n. And the reverse is true. True. Are you together? Yes. Then law number three. If I have an index which is a to the power n, again raised to another power m, what does the law say? We multiply the what? We multiply the power. So which means this one will give us a m m n.
Yes.
Now these are the three fundamental laws. All other laws that we shall look at will come from these three laws. Okay? These are the first three fundamental laws. So when you are multiplying, the result must be this. When you're dividing, you get that. When a number is raised to another power, you multiply the power. Okay? Is that one clear?
Yes.
Yes. Now we can go and look at other laws. Let's say other laws. Let's look at others now. Which I can call it. Let's say this is it. The first one. Okay. Now, from that law, I said now if I have 1 out of a to the power n, okay, that one now can be written as a to the power negative n. Right together?
Yes.
Then the next one we can also look at is a to the power 0. A to the power 0 is equals to 1. Any number raised to power 0 is it?
1.
Is 1. Then we can also have, if I have a to the power n divided by a to the power m, okay? But it's again raised to another power, let's say maybe another power k, okay? Now this power is going to be distributed for both the denominators and denominator. So which is the same as a to the power n k. So you multiply that divided by a to the power m mk. Are you together? That is when we have fraction. That is rational. This is for rational or quotient. Rational or quotient. Are you together?
Yes, teacher.
Yes. So we can also have a to the power b, a over b, again raised to the power n. You can also have something like that. So the law still also permit us to distribute the power. So the power is for a and for b. So this one is the same as a to the power n divided by b to the power n. Okay? So there are
Yes.
very many. We can generate thousands of them, but the most important one, the first three that we have looked at them. Right together. Now let's start proving them. Let's prove this law one by one. Let's prove this law one by proving. Let's prove this law one by. Yes, members?
Yes.
Yes, teacher.
Yes, teacher.
Someone is again calling my phone. That's why you are not able to see what is on the screen, okay? My writing, eh? But I will get back to you shortly. Just a minute, please. Just a minute. Someone was calling my phone again. Yes?
Yes.
So as I connect my phone, now you are able to see what is on the screen. The note. Are you seeing the note?
Yes.
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 So, that one is we are trying to prove the laws that we have just looked at them. We are just the laws, like the first one, that's for the first law. That's what we call the multiplication law. The multiplication what? Multiplication law. The multiplication law. So we are saying if I have a squared times a to the power 3, okay? We know that according to the law, a squared means we are supposed to multiply a how many times? 2 times. So a times a, again times a cube, which is a times a. So now when we combine all of them, you will see that You shall have A, but how many A is appearing there? There are 5, right? So we find out we shall have A to the power 5.
5.
Yes, it's A to the power 5. That's why we have it like that. The same even is applied to A to the power 3 and A to the power 4. Okay? So that one we are working normally. But if you have to use the law that we have just seen then, it's going to help us to save time. You know, mathematicians, we are interested in saving time. So we simplify it just by using the formula which I've just listed.
Excuse me. Okay, we're not speaking you well. It's some funny sound.
Yes?
Teacher, there's some funny sound I'm receiving. And you're so low. Are you able to see my screen now? Yes.
All right. So that one, what we are seeing that we are proving law number 1. Law number 1. We are proving law number 1. So when we go to, we can proceed. If I have, I can say also. If I have, like, take example, you have 2 to the power 3 time 2 to the power 4, right? Now using the law that we have just listed down, they have the same base and we are multiplying. What do we do to the powers? We maintain the base, which is 2, because they have the same base. So we just add the what? We add the powers, which is going to be 3 plus 4. Which means this one becomes 3, then 2 to the power 4 becomes 2 to the power 7. You can even prove it. Can we prove it? What is 2 to the power 8? I mean 2 to the power 3 is 8, right? Time. What is 2 to the power 4?
2 times.
2 to the power 4 is 16, not so?
Yes.
What is it? 8 times 16. What do you get? 8 times 16. What do you get? We get 120.
128.
Let's prove. What about 2 to the power 7? So when you are using a calculator, you come and press. Are you seeing this one here? Are you seeing what I'm putting my pen on? That. Are you seeing that? That's
yes.
what we use. That's to the power. That means to the power. Okay. So which means I come and put 2 to the power. Our power is what?
7.
Our power is 7 equals to, you see what we are getting? You see, it's also 120?
28.
It's also 128. So this is the shortcut we use to solve. I told you, mathematicians, we are interested in saving time. So we just save time just by using that formula. And it's a law. Members, it's a what? It's a law.
Hello.
So if you change it, and this law is only applicable when we are multiplying. When we are what? Multiplying. Someone may ask, why is that?
Multiply.
It's not the same as a squared plus a to the power 3. Are they the same? Are they the same?
No.
So this law, the one that we have looked at, does not apply to this one. It's not applicable to that. Are you together? But if you have a squared plus a cube, this one you add it normally. You added what? You add normally. What do you mean adding normally? What do you mean adding normally? So you just get answer for this, you get answer for this, then you add them together, okay? Are you together?
Yes.
Yes. So we shall take a break, then after the break we come and we continue from there, okay?
Okay.
Yes. Thank you. The break is only for 2 minutes, then after 2 minutes we join back. Keep time, please. Keep time, don't join late.